Thanks a lot for the introduction. Hello everyone and welcome to using Qt's 3D Studio to design embedded user experience on ARM devices. So the title is quite long. It's mainly about using Qt 3D Studio. I don't know, first I would like to check who of you already has some experience with Qt 3D Studio? Okay, that looks good, because it's really meant more as an introduction and it's not really advanced stuff, so yeah. So my name is Stefan Eichenberger, as I already said. I'm a field application engineer. I have some experience in embedded software development before. I'm not really a 3D expert in any sense. So I really had to learn how to use Qt 3D Studio from the beginning. Some words about Toradex. Toradex is basically a system on module provider. System on modules are small computers for people who don't know what it is. Toradex is focusing mainly on long-time maintenance and high reliability. And all of our modules come with a BSP, of course, and production-ready software. What that means is you can really easily flash your own image during production onto our modules. Toradex also has a partner ecosystem, which is interesting. So one preferred partner for user interface is, of course, Qt, and that's the reason why we are basically here. So my first question when I heard that I have to give this talk was, why should we use 3D? And I remembered one talk from NVIDIA where they were talking about their AI framework, and they mentioned that to give the passenger some confidence about the car, you should, for example, show them what the car sees. So if you are a passenger in a car, imagine you have to leave the highway in 100 meters and you have a car next to you. Then you can get a little bit unconfident because maybe the car will drive right and there is still another car. What you can do then is, if you show the car to the passenger, then he knows, okay, everything is fine because the system detected the other car. So in this scenario, the blue car would be our car, and the red car would be the enemy car, let's say. Well, of course, it's the other car. So as I said, I had to learn Qt 3D Studio, so I thought, what can I do? Then I thought, okay, I have to give this presentation. So what I did is I basically did the presentation with Qt 3D Studio. This here should show a simulated Berlin Wall with a watchtower in the back. So my colleagues told me no one will notice what this is. So I have to tell you it's a watchtower, basically. And the rest is the Berlin Wall with some graffitis on it. So. And yeah, here as well, you can see it's all about context. So the reason why we show it, you can give the user some information about 3D context. It's not as with 2D UIs where you normally can show them where they are in the global world. So one other thing that you can do, of course, with 3D is you can do transparency, and the advantage if you do that in 3D or on a GPU at the end is that you don't have to use your CPU. So you can offload the load that you normally have to do on CPUs to do transparency to the GPU. That's one other advantage why you may use 3D. Of course, QML, for example, already does that for you. If you would use QML and transparency, that is done on the GPU as well. So it's not really the main reason why you should now use Qt 3D Studio. if you once have to select an embedded device and you want to run Qt 3D Studio, so what should you do? Device provider normally show you some block schematics like this one here. This is from an IMX6. Then you have some core complexes for high-end applications like the Cortex A72, or for low power stuff like the Cortex A53 and some real-time stuff with Cortex M4s. Then you have, of course, peripherals. You have also memory interfaces. And what is the most important thing is basically a multimedia GPU. So that's basically what renders at the end your 3D stuff. On an IMX8, you have even 2 GPUs, so this means you have twice the same IP on the chip. And each of these GPUs have 8 shaders or shader cores. Basically, one shader core can calculate for a vector of length 4. So this means in Vivante language, you have 32 shaders per core. Yeah, then some advertisement for Toradex. As I said, we are a system on module provider. We have, of course, a solution with the IMX8 Quad Max. It's an early an alpha release still, so it's an early silicon. That means it's not meant for mass production yet. We have some sample products, but you shouldn't use it in a volume product at the moment. We hope that it will be released finally next year somewhere. So how do you start if you want to do Qt 3D Studio? So it's, first you can install on an embedded device, you can basically install boot to Qt. There is already a boot to Qt preview available for the Apalis IMX8. Then you have to compile, or at least that was my last status, you have to compile Qt 3D Studio for Linux. There are binary versions available for Windows and also for Mac OS. After that, you need to compile the 3D runtime for IMX8. That was true until Qt 5.11.1. Now it's a previous already installed in boot to Qt images. Then, of course, you have to deploy it. If you don't, so that's also not necessary today because it's integrated into the boot to Qt image. But you have to deploy the Qt viewer, which we will see later, and the libraries of the Qt 3D Studio runtime. And then, of course, you can start with the sample project. So the sample I would really recommend you, if you don't have any experience with it, to start with the sample project because it's quite complicated maybe, and so that you get a little bit familiar with the Qt 3D Studio. So let's assume you have your car, or in my case it was the watchtower. You have that designed somewhere in another 3D editor. In my case it was Blender. Blender is open source, but you can also use AutoCAD or any other 3D editing tool. Then you have to export this object into a Scolata file so that you then can import it into Qt 3D Studio. And in Qt 3D Studio, you can do the global placement. You can say where your watchtower or your walls are. Then you can do also animations. You can define slides and so on. So we will see what you can do, basically. Now, if you have a first preview of your application, what you can do then is, if you want to run it on an embedded system, you can start the Qt 3D viewer. That is this binary that I was talking about before, that you should deploy together with the libraries. When you start this application, before you start it, you have to basically stop the Qt launcher, because boot to Qt automatically starts the Qt launcher. That you have to stop. That is system control stop Qt launcher. And after that, you can start the Qt 3D viewer. The Qt3D viewer will then show you a screen where it says which IP that it has, and then you can enter that in a Qt3D Studio, connect to it, and then it will automatically deploy your current view to the Qt3D Studio viewer. Some parts that are nice to know where I had some trouble at least. So when I first imported the watchtower into Qt3D Studio, it wasn't showing all faces. So you had really holes in the tower. What you have to do in Blender is you have basically to activate the backface culling to get rid of that. Then you will see, so backface culling that's an optimization technique by OpenGL. What it does is it tries to, on the orientation of the vertices points, it tries to find out if it has to render the face or if it can skip it. The disadvantage of this is if it's wrong, then it won't show it. And in Blender, what you need to do is you have to basically press N, and then you have to say, okay, I want to see backface culling. When you see that in Blender, then you can fix it, of course, and that you can do with Control N. The other thing you have to know is, or should know maybe, it's the texture mapping. So assume you have a texture mapped somehow on your surface. Then it can be that it looks quite ugly. You have distortions, like on the left side. What you can do there, you can go in edit mode, press U, and then select unwrap. And what this does, it tries to rearrange the mapping of the image to the edges of your surface. And then it should look much better. You can also do that manually. It's called the UV editor, where you can set the points of the edges directly in an editor. So. And then with the Qt Studio, so as I said, it's for me, with no experience with 3D, it was first kind of confusing, because what I wanted to do, for example, if I have a camera and I want to animate this camera, I would expect if I right-click, then I can add an animation. But that's not the case. So what you have to do if you have a camera and you want to animate this camera, so the movement of the camera, you have to click on this small symbol on the top, and then it will automatically add you the animation on the bottom. The other thing is you have to work with keyframes. So what this means is you can set the position of the camera. Then you press S, then it stores the current position of the camera in somewhere, so in the project file basically. And then you can move the time slide, move the camera, and then press S again, and then it will automatically animate the transformation from position 1 to position 2. You can do that with angles as well, and with all kinds of, with transparency. For example, this is what I did with the, so I have to start different. There are other things that's a component. So a component can have, again, their own slides. So the slides are the things on the left side. You have a master slide, and then you have several sub-slides. The master slide is like in Excel. It's in Excel, in PowerPoint, it's basically the main slide. And all other slides will inherit that information from the master slide. A component can have, again, its own master slide and then its own animations. So this was, for example, the thing that I did with the transparency before, where you could see if I press enter, then I only changed the slide from a component instead of the slide of a top-level slide. One thing that is typical or is is only valid for embedded devices at the moment, and I think they will fix that in later releases. The standard materials weren't working correctly. So if I wanted to have concrete material, for example, for the watchtower, then it was simply not rendering it on the embedded device. And yeah, I don't know why this happens, but as soon as I change to standard material and add the images by myself, then it was working. So I think that will be fixed in the future. One other thing that I really liked was that the project files are basically in XML. And the advantage of that is you can script it, because for this presentation, I would have to place the camera. I would have to create a slide for each slide here, and then I would have to place the camera manually. And because I'm a lazy person, I decided to write a small Python script that parses basically the project files and tries to find the location of the camera by itself, so that I don't have to do that manually. You can, of course, integrate your Qt3D project also into QML. What that means, it's really easy. So you have only to specify the source of the UIP file. You have to include all your maps, images, and so on into the QRC part of Qt. And then you can, for example, add your own key events, like I did here, for example, on left pressed, then it will change the slide. I use that so that I can show you this presentation, basically, because the default isn't that you can only say on press event, and for me it wasn't working very well. So with QML it then works perfectly. And here again, if you want to deploy your final Qt application to the target, you can of course use this time Qt Creator and use your normal launch button to deploy the application to the target. Okay, so that's it basically from the the demonstration on the PC. Now I want to show you. Hopefully it works, because that's never so sure. It should do the same thing basically on the. Ich muss noch kurz die. Voilà. Das sollte, glaube ich, gehen. That's it. So, hier. Und vielleicht über den Demo, wenn das möglich wäre. Ja, genau, das möglich wäre. Okay. So what you can see here is it's now basically the exact same demo as you saw before, running on the laptop, but now it's running on an IMX 6. And you can see it renders really smooth. So you have almost no stocking or flickering or anything. Also transparency works quite well. This one is now an IMX 6, not an IMX 8. The reason why I've chosen is this IMX 6 is that we don't have that many IMX 8 left. And also the power consumption is a little bit less, and we had to modify the Xora board for the IMX8. So it's really that easy. You can use the exact same application on the IMX6 as you used on the PC, or you can also use it on the IMX8. So okay, that's it from the presentation side. So now, do you have any questions? Yes. I'm sorry, can you repeat the question?
When you build or deploy, can you choose if you want to use OpenGL ES or Vulkan, or is that?
It does it automatically, so it chooses the best that it finds. So in the case of the IMX6, it is OpenGL ES2, or 2ES. With the IMX8, it should also use real OpenGL because it supports it. But the problem with the IMX8 is, at the moment, the BSP isn't that stable. So Qt had to do some twerks to make it basically running on the IMX8. But in the future, I'm sure NXP will fix that, because as soon as they release the next silicon, it will be fixed for sure. Okay, other questions? Okay.
Thank you to the audience. Thank you to Stefan.
Thank you very much.